Hello everyone, welcome back to the channel. We're trying to develop self-driving cars in a simulator. Today we're going to be talking about taking reinforcement learning from the very basics further. And we'll be talking about the obstacles on the way, what we've achieved so far, what the different pitfalls you can find along the way, and how to overcome them. I've been training some more models between at meantime, but they're not quite there yet. So I just wanted to put all my thoughts together and give you my latest on how to start developing reinforcement learning further. Now, what we've done before is we achieved a few things. First of all, we've successfully connected the stable baselines 3 to Kala simulator and got the reinforcement learning working. And then we trained the model to steer the car somewhat successfully in generally just one town, which is already a great achievement, which means we can see that we can leverage reinforcement learning and get the car what we want to do. But as part of that training, we use just one of the algorithms that comes in stable baselines 3, which is PPO. There is a lot of other things we could theoretically try. But I think that given that PPO is somewhat working for us, we just need to focus on getting the car do a few other things well before we try maybe other algorithms. So from here, what I've realized, there is a lot of possible branches or rabbit holes that we can go from here. But obviously, if we were to summarize context, what we're trying to achieve here is to train a model to do a task of, okay, car, get from this point in this map to that point, don't hit anyone, and arrive to that point in the shortest way and in the fastest way. So that's all we wanted to do well. That is quite complex. Obviously, it needs to not crash into other cars, not to run over any pedestrians, obey traffic lights, all of the above. So that is quite complex, and that's what we're trying to get to from this point, right? But before that, let's just do a little recap on reinforcement learning training, just to refresh your context. So the reinforcement learning engine for which we're using stable baselines 3, we use effectively reinforcement learning in an outsourced kind of way. We using a nice off-the-shelf free software, so we don't have to tinker around for all the strategy and policies and everything. So we can focus on the rewards policy here and what we're trying to get the car to. So from the reinforcement learning engine, it's trying to fire off random actions, which is steering, throttle, braking in our context, and then see what happens through this observation loop. And one of the observations could be images that the car sees next, or it could be collisions and some other things that are coming through rewards, and episodes are stopped if a collision is detected, and obviously appropriate amount of punishment and negative rewards are coming through in that situation. So that's our reinforcement learning refresh very quickly, very simply. At the end of all this, we save a policy, which is essentially policy or a model that what we're trying to achieve, and that will be the thing that will drive the car in the future. As long as we're happy that this policy is okay, it could be as easy as driving it in a simulator and as complex as putting it into a real car and sending it on its way. All right, good luck with that one. So that's the reinforcement learning context. So to get there, we need to do a few things. First of all, so far we've only managed to train the model to steer, so we need to add throttle and braking. We also need to add traffic and make the car see other participants of the roads and not bump into them, and obey all traffic rules and do the right things. The next thing is we need to give it a navigation objective, which is obviously quite important. And we also need to make sure that it drives smoothly, keeps to the center of the lane, all of those nicer things that we could possibly refine later. So the points up the top are probably more important, and they reduce in the order of importance as we go down. So we will be talking in this presentation of, okay, how we do all of those things. And I hope it will be very valuable for you. And this is all about the context and what we're trying to do and what the obstacles are on the way, rather than, just dumping a piece of code on you and then you just use it and say, hey, it's nice, so what, okay? So there are a few things that we've learned as we've done what we've achieved so far. So we need to make sure that the car we use the spin factor at the car initiation. Otherwise, the car will drive straight, but we'll get to that point on the next slide where I go into these points into a bit more detail. One of the most important things that we realized is that we need to pre-process initial camera image and rearrange it into a somewhat simpler form. And essentially, it's also an array as the initial image, but then we're just simplifying it. Then we also need to change our environments as we tweak it. So our abilities to change environments and continue training essentially the same policy is remarkable. This is the functionality that allows us into, going step by step. And it's just great that we can tweak the environment, change the rules, change the reward policy. And the rewards is where most of, unexpectedly or unexpectedly, playing with how you set up rewards for different things and punishment for other things is very tricky, but that's the only way we can leverage reinforcement learning and make the car do the things that we want, or make it do the right things and stop it doing the wrong things, all the kind of things. That's very important. However, it's quite tricky, as we've discovered in just what we've done so far. Now, from the tricks that we've learned, going one by one. So when we spin the car at the start, this is what I'm talking about. We essentially just spawn the car at a particular, or at a random location, and that's what's happening in reality before the car gets going. So this thing essentially forces the car to learn how to steer, because our objective was steering. So we kind of we were throwing it into the deep end. So it just, if it doesn't steer, if it doesn't find something to do with steering and get it right, it will crash into something. So otherwise, the reinforcement learning is a very dumb thing. And so the car will try the easiest path to increase reward, and it may not get to the place that you wanted. And in many cases, it would result in just the car driving straight and just ignoring anything else. So it will think, okay, it's probably easiest. I'll get more rewards just driving straight and stay in this lane. And then eventually hit, when the road turns, or hit something after the intersection. But it's better than just trying to figure out other things. That's what's happening. So by giving the car these random yaw angles at the very beginning, we force it to learn the steering straight away. Okay, that's one of the very important things that we've learned, and one of our tricks in our toolbox for the future. What we've also learned is we need to pre-process our original image, and by pre-processing, not only we convert it into a simpler array representation, but we also may need to crop it just to get the meaningful part of the road. Obviously, this is not looking for traffic lights, because you can see this could be a traffic light and we're completely ignoring it. However, or no, it's actually a lamppost. Anyway, you get my point. So courses for this particular application, we just going into this direction, into steering. Imagine we could theoretically have another branch and another image going into traffic light detection algorithm at the same time that we could add later in parallel. So we could still be producing this for steering, but then for other functions such as signs and traffic lights, we could have a different branch of our logic going in parallel. Okay, that's another trick that we've learned. And then also the environment. So what we can change between our sort of learning sessions is, at the end of each session, the latest model is saved. So what we're essentially talking about is the next round of iteration. We can open the same model and then continue training. But before that, we could change our environment. And those changes may include the actual environment change. Like, for example, we can reload other towns, other maps, although we can do it as part of the same sort of training session. But we can tweak the weather if we wanted to, or more or less traffic. So we can change all of those parameters to make it more suitable for whatever we're trying to model to learn next. If we are, for example, trying to not bump into cars, we may introduce more traffic and just force the car to detect those situations and apply brakes and all of those kind of control inputs. We can also adjust our reward policy, and this is what we essentially will be doing. We imagine if we're trying to get the car to run smoother after it learned how to navigate and how to get to one place and how to not crash into things. The smoothness refinement could be just giving it extra rewards for doing the right things. And again, hopefully that makes sense. this is a great way for us to manipulate what we need the car to do, and our ability to manipulate our environment from one training session to another is just great. Now, the very important caveat here, we need to make sure that in all of that, our action space, or, for example, steering, braking input, and throttle input, that defines as an action space. So that space needs to be the same throughout. So even if we try to, at the like what we've done before, if we just need to learn steering, we also need braking and throttle to be present as controls at the very beginning before we get the model to learn steering. Because later, as we will be adding braking and throttle in the next iterations of the training, we need to be able to have them defined or declared at the very beginning, and that's an unfortunate limitation. The same goes with observation space. If we all of a sudden want to pass into our sort of feedback loop besides the image, if we decide, okay, we just need to feed the current speed as well. So we need to make sure we do it before we start even the first round of model training. And these are the unfortunate limitations. And otherwise, you'll get an error because, you saved one policy and then you modify the environment and that environment starts including new control inputs. Then you'll get an error that your environment and your policy are misaligned. So you will not be able to proceed. So therefore, your environment, including observation space and action space, should be consistent throughout these modifications. And you may ask, what happens to throttle and braking if we only train steering? So we will essentially ignore it in the code, right? So imagine if the model is trying to play with throttle or braking while we only expected to do steering, then all of those will be ignored, like there will be no outcome whatsoever. So I'm assuming it will be detecting that it doesn't provide any difference whatsoever. The outcome is exactly the same every single time. So at some point it will just stop changing them and ignore them. So, but then when we start using them and connect them to the actual input into the car, then it will realize that it will need to start changing them to improve it. So that's effectively how we do it. And now, as far as rewards are concerned, the model is very dumb. So there are a few lessons that I've learned as I was trying to do this, and think of it as a very dumb engine to get to the easiest rewards path. So this is where driving in circles come from. If you may, for example, reward the car for making distance, so it may decide, okay, if I put the steering to lock one side or the other and just do laps, it will achieve this objective. Another example that we already covered is with driving straight, all of those things. So, or another example that I found that, when I try to also get the car to learn throttling is, I thought, okay, we just need to make sure it gets off the ground very quickly. So I was rewarding the car to start moving or, getting some speed in the initial part of the episode. But then what started happening later, it realized very quickly that once it got going, it doesn't matter. And then if it slows down later and it's not being punished for that, so it may slow down later. So what I had to do is just to constantly check the average speed over the last few iterations or time steps and reward it for not to have that speed in a certain range. And then that's what it takes. You just need to be very careful, otherwise it will find a loophole in your logic because it's just dumb and it's just trying to get to the maximum reward as quickly as possible. Another point I would like to make here is the balance between different reward components. Imagine example where you given rewards per time step, like for example every iteration, like over every frame of the simulation, and if the car makes a certain distance, you give it like a couple of points, and then you just need to keep in mind that all of those time steps keep accumulating. So if you give it a couple of points over the course of like 20 seconds, it may end up quite a significant amount. So if you punish the car for crashing into something by 300 points or 500 points, whatever, you just need to be mindful like how those two components are balanced against each other. So for example, if you make the punishment is very small, like 10 points, but you give 2 points for every meter traveled, then the car will become very risk-taking, because it will just realize quickly, I just need to make as much distance as possible, and if occasionally I crash, the punishment for that is not that big, so therefore the best course of action is just floor it and fly. And that's what I'm talking about. The balance is between different components of rewards is what you just need to be mindful of. And unfortunately, all of those is intuitive. There is no way of models, or I suppose you could design one, but it's all manual. Like you decide, okay, I penalize the car for crashing into pedestrian by 1,000 points. Penalize the car to crash crash into cars by 500 points, and then okay, and that's your basis. And then when you play with other elements of your reward policy, such as rewards for distance travel, you just need to be, kind of mindful, okay, how you give those rewards, like what sort of total accumulated amount they could get to on average, and you just need to be mindful of those things. All right. Now, again, thoughts about where we're going next, because just to recap, we need to add throttle, braking, traffic, navigation, and then refine everything so that it's actually comfortable to be in the car if it gets to a real road and driving a real passenger. So each of those things in a bit more detail. So the throttle and braking. So that's what I've been doing since I published my last video. I've been trying to learn to get the car learn throttle with steering at the same time. And by the way, the code, the only difference as far as defining in the model or in the environment, the action space, it becomes this array. So the first control element, and let's assume this is steering, or this is steering, has 9 possible inputs. And then the same for throttle, and braking will have 4. So I didn't want to go into continuous spaces. So what this means, these are discrete values, and we map it in the code like this. So if you have 9 possible steering actions, so 0 would equal minus 0.9, or steer to the left to almost maximum. And then somewhere in the middle, that the value of 4, which is the middle in the sequence of 9, will have steering of 0. And then these points 3 and 5, which are around middle point, they just have minor, to the left, minor to the right. It kind of lets you steer the car in a very small increments when you want to, near the middle, but then when you go quite far left or right, the increments become quite large. And for throttle, it's because it goes from 0 to 1, you can kind of break it. So there are various degrees of not giving it any throttle to 0.1, 0.2, and all of those things. Hopefully that makes sense. So essentially, you give the model can only input into the car 9 possible options when it comes to steering, 9 possible options to throttle, and then 4 to brake. And I assume there needs to be some variability, like how hard you want to brake. And then essentially the way to add, like say, for example, after steering, you want to add throttle, you have 2 options. You train one thing, save the model, and then continue training the other thing. Well, initially you ignore all the others because they've been already defined, but the model is just not using them or not sending whatever it tries to into the car. But then in the next iteration, when you, for example, train the model to steer quite well, then you may decide, okay, now I want the model to steer. And then you tweak the reward policy, actually pass the inputs from the model into the actual action space controls. And then, hopefully it will learn it as well as a next sort of addition. I haven't done it yet. I've been using second option rather, where steering and throttle together are being learned from scratch. And, I'll show you a couple of little snippets at the end where I got to. And believe me, it's a tricky process. And currently what I've done is, in the option 2, the approach that I've got is I reward the car to give sort of 2 points per time step if the average speed is within 15 to 30 kilometers an hour. And then I actually deduct points, and I deduct more points as we get further away from this. Like if at 0, I just subtract like -5 or something like that. And if the average speed over the last 10 time steps is within this range, then I give it like 2 points or something. So it will, the objective here is to push it to realize quite quickly that, if it throttles to maintain the speed within this range, it gets maximum reward. And that's what I've been trying to do so far. Now, next thing, one of the things that I found here is throttle is very confusing for just giving the car just the image, because imagine the model, all it has is just one current image, like for example, reading of the front-facing camera, and it's just one image. And from that, it decides how to steer and how to throttle. So as humans, we maintain sort of history when we drive. Like, for example, we know the situation, we know speed. So here, the model does not have all of those things. It's just the current image, not a sequence of images. And therefore, it does not have like a good input or good source of knowing what the current speed is. And essentially what it leads to is, I will show you. So these are just snippets of how my current model is testing. And it's a model that was trained based on throttle and steering together. And you see it's not great. And one of the things that you may have noticed is that in certain situations, if it sees a certain view, like for example, it's at an intersection. So generally it knows, or it learns that if it runs quite fast at an intersection, it will likely crash. So what it leads to is like when the pictures may start looking like the car is at an intersection, it just doesn't want to add throttle at all. So you see where I'm getting to. We need to add speed into our feedback loop, and I was just trying to look into it, and you can see what Google's AI engine suggested, that it suggested to use the tuple as an observation space. You basically send it a tuple of the image and the speed as a number. So the image is an array and the speed is a certain number. But again, when I tried, I got an error because the stable baselines 3 does not support, or that particular algorithm, the PPO, does not support tuple observation space. So we may need to solve it. And this is just one of those rabbit holes that, I discovered, and it needs solving. So you need to pass on the speed to the car. Obviously, it's very important for all the reasons. So the way to do it is possibly to sacrifice the way we send our pre-processed simpler representation of our front camera image. We need to essentially lump another bit to it, but the way to do it is, because it's a 3D sort of array, you can't just add one number. You can you either flatten it so it becomes just one flat vector, and you just add another space to it with like a number representing the speed, or you could potentially add another layer, imagine RGB, you've got red, green, blue, and of course it's not at that point already, so we've got shape of 7, 8, 18, 7, 18, 8. So this would be just adding, making it 9 and then repeating that speed across multiple things. Hopefully it makes sense, but it's not an elegant solution. I will probably be exploring just flattening the array into a single dimension vector and then just adding speed to the end of it. So again, you can see just with reinforcement learning, we could discover new rabbit holes as we go. It's not that easy, but these are the kind of problems that we need to solve to get the car to the right things. And about adding traffic, which we will need to do later, I still haven't done it. So the only initial thought that, as I've got at this point, is I'll probably use braking when I add traffic, so to give the car ability to slow down quickly if it sees something in front of it. And I will probably, because to be humane and not look cruel, I will probably add quite a bit of punishment for collisions with pedestrians than for collision for the cars. So I will make it very clear to the car that it's not all right to bump into things when pedestrians and cars are on the road. And that's the only thoughts I've got on adding traffic. Now, my notes or comments on navigation. We've done it before, and you've seen how we do like waypoints. There is a function that I've used in my earlier tutorials to show you how to create a route, and routes are made up of multiple waypoints. So one quick shortcut would be to feed back to the model or to ask the model to go to the next waypoint and to give that angle. But interestingly, that angle is the very thing that the model will need to work out. So it's like if you give it straight away, so it's like cheating, so it doesn't have a chance to work it out. So what I've got in mind, right? So imagine if we've got we got to get to an intersection, and imagine our car is here, and if we wanted to go left, so obviously our waypoint or the route is kind of this way, okay? So as I said, we can't just give the angle to this waypoint. So, but the way to kind of go around it is maybe blue pen, maybe to give it an angle to kind of this point. It's like jump, I don't know, 10, 15 points and give that angle. So when the car sees this, so obviously it's kind of, the objective here is to actually follow that route. So, and following that route, it will be made up from all the other constraints in the model, like it needs to be in the center of the lane, or this is the most appropriate trajectory through an intersection. So even despite it having that angle, so it needs to still follow to get there the right way. And another point here is like speed. It also, this angle needs to be fed back into the model. So you can see like a lot of things are adding up to the fact that, oh, we may need to start things from scratch again as soon as we figure out how we add speed, and we also figure out how we feed navigation objective into the model. So as you can see, quite a long way to go still there. And if we go to the next slide, as far as refinements are concerned, this is probably the easiest, and I'm happy to leave it for the future, but all the things around how to make the car being in the center of the lane, and including the previous slide, the navigation through an intersection, how to draw that trajectory, all of those things are about just getting the right information from the simulator. Like for example, you can get the lane information in the center of the lane, so you can calculate quickly how far off the center of the lane you are, so you can give reward if you're close or further away from the center of the lane, that kind of stuff. Obviously you need to know whether where you are at the moment is an intersection or junction or just a normal lane. So that also depends on how you give rewards on the best way to go through an intersection and stuff like that. Here you will also have which lane to be in. It kind of in between previous point on navigation and like the refinements. What's the best course of action, like which lane to be? Is the slowest lane to be a good driver on the road, to not be in the fast lane without a good reason? I don't think it actually flies these days as a good reason, or you know, respecting other people is another story that we could start another channel again, but this is where it kind of sits. Okay, now that was it for today. I hope this was useful for you. We were just talking about various aspects, how to start developing your reinforcement learning for self-driving from the very basics, and like the obstacles are on the way to make it more advanced, and how my strategies to go around it. And again, hope it was useful, and I look forward to see you in the next video. Thank you. Like and subscribe, the usual. See you. Bye.